Bridge rectifier applications. Bridge rectifiers are widely used in various electronic circuits where conversion of alternating current, AC, to direct current, DC, is required. Here are some common applications. Power supplies are one of the primary applications of bridge rectifiers. Here's how bridge rectifiers are utilized in power supply circuits. AC to DC conversion. The main function of a bridge rectifier in a power supply circuit is to convert alternating current, AC, from the mains power source into direct current, DC. The bridge rectifier accomplishes this by rectifying the negative half cycles of the AC waveform to produce a unidirectional DC output. Full wave rectification. Bridge rectifiers provide full wave rectification, meaning they rectify both the positive and negative half cycles of the AC waveform. This results in a smoother DC output compared to half-wave rectification, where only one half of the AC waveform is rectified. Low ripple. Bridge rectifiers produce a relatively low ripple in the DC output compared to half-wave rectifiers, leading to a more stable and consistent DC voltage. This is beneficial for applications requiring a steady power supply, such as electronic devices and equipment. Filtering and regulation. After rectification, the DC output of the bridge rectifier may undergo additional filtering and regulation stages to further smooth out fluctuations and maintain a constant output voltage. This ensures that the power supply delivers a reliable and consistent voltage to the load. Voltage transformation. In some cases, power supplies may incorporate transformers before the bridge rectifier to step down or step up the voltage from the mains power source to the desired level. The rectified DC output voltage can then be further regulated as needed. Isolation. Depending on the design of the power supply, isolation may be provided between the input, AC mains, and output, DC load, circuits to improve safety and prevent electrical hazards. Isolation transformers or opto-isolators may be employed for this purpose. Output protection. Power supply circuits often include protection mechanisms such as overvoltage protection, overcurrent protection, and short-circuit protection to safeguard both the power supply and the connected load from damage due to electrical faults or fluctuations. Overall, bridge rectifiers play a crucial role in power supply circuits by converting AC power from the mains into stable and reliable DC power for a wide range of electronic devices and equipment. Bridge rectifiers are essential components in battery charger circuits, facilitating the conversion of alternating current, AC, from the power source into direct current, DC, suitable for charging batteries. Here's how bridge rectifiers are used in battery chargers. AC to DC conversion. Similar to power supplies, the primary function of a bridge rectifier in a battery charger is to convert AC input voltage from the mains power supply or another AC source into DC voltage. This rectified DC voltage is used to charge the battery. Full wave rectification. Bridge rectifiers provide full wave rectification, ensuring that both the positive and negative halves of the AC waveform are converted into DC. This results in a more efficient charging process compared to half-wave rectification, where only one half of the AC waveform is utilized. Constant voltage charging. Many battery chargers employ constant voltage charging, where the charger maintains a relatively constant DC output voltage across the battery terminals during the charging process. The bridge rectifier, along with voltage regulation circuitry, helps achieve this by providing a stable DC voltage to the battery. Current limiting. Battery chargers often incorporate current limiting features to prevent overcharging and protect the battery from damage. The bridge rectifier, along with current sensing and control circuitry, regulates the charging current supplied to the battery to ensure it remains within safe limits. Pulse charging. Some battery charger designs utilize pulse charging techniques, where the charging current is delivered in short pulses rather than continuously. The bridge rectifier facilitates this by converting the AC input into a series of pulsating DC pulses, which are then controlled to achieve the desired charging profile. Float charging. In applications where batteries are continuously connected to a charger, such as in standby power systems or automotive applications, float charging may be employed to maintain the battery at a fully charged state without overcharging. The bridge rectifier, along with voltage regulation circuitry, supplies a constant voltage at a lower level to keep the battery topped up. Charge indication. Some battery chargers incorporate charge indication features to signal the user when the battery is fully charged or in a particular charging state. The bridge rectifier and associated monitoring circuitry play a role in detecting the battery's charging status and controlling the charge indication mechanism. Overall, bridge rectifiers are integral components in battery charger circuits, enabling the conversion of AC power into DC power for efficient and controlled charging of batteries across various applications, including consumer electronics, automotive systems, and industrial equipment. In motor drive systems, bridge rectifiers serve several crucial functions, primarily related to converting alternating current, AC, power into direct current, DC, power to drive the motor. Here's how bridge rectifiers are used in motor drives. AC to DC conversion. The primary role of the bridge rectifier in motor drives is to convert AC power from the mains or another AC source into DC power. This rectified DC voltage is then used to power the motor drive circuitry. Full-wave rectification. Bridge rectifiers provide full-wave rectification, ensuring that both the positive and negative halves of the AC waveform are converted into DC. This results in a smoother and more efficient power supply compared to half-wave rectification. Variable speed control. Many motor drive systems require variable speed control of the motor. Bridge rectifiers, along with associated control circuitry such as pulse width modulation, PWM, controllers, enable precise control of the DC voltage supplied to the motor, thus controlling its speed. Direction control. In addition to speed control, motor drives often require the ability to change the direction of rotation of the motor. Bridge rectifiers, combined with reversing switches or control algorithms, allow for seamless reversal of the polarity of the DC voltage supplied to the motor, thereby changing its direction. Current regulation. Motor drives may incorporate current regulation features to limit the amount of current supplied to the motor, protecting it from overload conditions. The bridge rectifier, along with current sensing and control circuitry, helps regulate the motor current to ensure safe operation. Regenerative braking. Some motor drive systems utilize regenerative braking, where the kinetic energy of the motor is converted into electrical energy during deceleration or braking. Bridge rectifiers play a role in rectifying this generated electrical energy, which can then be fed back into the power supply or stored for later use. Integration with control electronics. Bridge rectifiers are often integrated into the overall control electronics of the motor drive system, which may include microcontrollers, power transistors, gate drivers, and other components. These electronics coordinate the operation of the motor drive, including speed and direction control, current regulation, and other functions. Efficiency improvement. By converting AC power to DC power efficiently, bridge rectifiers contribute to overall system efficiency, reducing energy losses and improving the performance of the motor drive system. Overall, bridge rectifiers are essential components in motor drive systems, enabling the conversion of AC power into controlled DC power for driving electric motors in various applications, including industrial automation, robotics, electric vehicles, and HVAC systems. Bridge rectifiers play important roles in various lighting applications, facilitating the conversion of alternating current, AC, power into direct current, DC, power necessary for powering lighting elements. Here's how bridge rectifiers are utilized in lighting systems. LED drivers. Light-emitting diodes, LEDs, require DC voltage for operation. Bridge rectifiers are used in LED driver circuits to convert AC power from the mains into DC power suitable for powering LEDs. LED drivers often incorporate additional circuitry for current regulation, dimming control, and protection. Fluorescent lamp ballasts. Fluorescent lamps require high-voltage AC to initiate the discharge within the lamp. Bridge rectifiers are used in ballast circuits to convert the AC power into high-voltage DC power required for lamp ignition. Once the lamp ignites, the ballast circuit regulates the current flowing through the lamp. Halogen and incandescent lighting. Some halogen and incandescent lighting systems utilize bridge rectifiers in their power supply circuits to convert AC power into DC power for powering the light bulbs. This is particularly common in low-voltage lighting applications where AC voltage needs to be converted to low-voltage DC. Street lighting. Bridge rectifiers can be employed in street lighting systems to convert AC power from the mains into DC power for powering LED street lights or other types of luminaires. This allows for efficient operation and control of street lighting networks. Emergency lighting systems. Emergency lighting systems often incorporate bridge rectifiers to convert AC power from the mains into DC power for charging backup batteries. In the event of a power outage, The stored DC power can be used to illuminate emergency lights, providing illumination during critical situations. Lighting controls. Bridge rectifiers may be used in lighting control systems to convert AC power into DC power for powering control circuitry responsible for functions such as dimming, color temperature adjustment, and smart lighting features. Outdoor and landscape lighting. Outdoor and landscape lighting systems may utilize bridge rectifiers to convert AC power into DC power for powering LED or other types of outdoor lighting fixtures. This allows for energy-efficient and durable lighting solutions for outdoor environments. Signage and display lighting. Bridge rectifiers are used in signage and display lighting applications to convert AC power into DC power for illuminating signage, billboards, and display panels. This enables the creation of vibrant and eye-catching lighting displays. Overall, bridge rectifiers play crucial roles in various lighting applications, enabling the conversion of AC power into DC power necessary for powering different types of light sources, from LEDs to fluorescent lamps, in a wide range of indoor and outdoor lighting systems. Bridge rectifiers are not typically used directly in audio amplifiers, as their primary function is to convert alternating current, AC, to direct current, DC, which is not directly related to the amplification of audio signals. However, they may be indirectly involved in certain aspects of audio amplifier circuits. Here's how. Power supply. While bridge rectifiers themselves are not part of the audio amplification circuitry, they are often used in the power supply section of audio amplifiers. Bridge rectifiers convert AC voltage from the mains power supply into DC voltage, which is then filtered and regulated to provide the stable DC power needed to operate the amplifier circuitry. Rectification and filtering. The rectified DC voltage produced by the bridge rectifier undergoes filtering to remove any residual AC ripple. This filtered DC voltage is then used to power various components within the amplifier, including the preamplifier stage, power amplifier stage, and other circuitry. Biasing circuits. In some audio amplifier designs, bridge rectifiers may be used in biasing circuits to provide a stable DC voltage reference for biasing transistors or tubes in the amplifier circuit. This ensures proper operation and stability of the amplifier's output stage. Protection circuits. Bridge rectifiers can also be used in protection circuits within audio amplifiers to protect against overvoltage or reverse polarity conditions. These circuits may prevent damage to the amplifier and connected speakers by shutting down or isolating the amplifier in case of abnormal voltage conditions. Power amplifier design. Although not a direct function of bridge rectifiers, the design of the power amplifier stage in audio amplifiers often takes into account the characteristics of the DC power supply provided by the rectifier circuitry. Proper power supply design, including rectification and filtering, is crucial for achieving optimal amplifier performance, such as low distortion and high-fidelity audio reproduction. In summary, while bridge rectifiers themselves are not integral to the audio amplification process, they play a vital role in providing the necessary DC power supply for the amplifier circuitry to function properly. Proper power supply design, including rectification and filtering, is essential for achieving high-quality audio performance in audio amplifier systems. Bridge rectifiers are not typically used directly in heating, ventilation, and air conditioning (HVAC) systems. However, they are indirectly involved in certain aspects of HVAC system operation, particularly in control circuits and power supply units. Here's how bridge rectifiers may be used in HVAC systems. Power supply units. HVAC systems often include various electronic components and control circuits that require direct current, DC, power to operate. Bridge rectifiers are commonly used in the power supply units of HVAC systems to convert alternating current, AC, voltage from the mains power supply into DC voltage. This rectified DC voltage is then regulated and distributed to power the electronic components and control circuits within the HVAC system. Control circuits. Many modern HVAC systems incorporate electronic control circuits for monitoring and regulating temperature, humidity, airflow, and other parameters. These control circuits may utilize DC voltage supplied by the power supply unit, which is generated using bridge rectifiers. The rectified and regulated DC voltage powers microcontrollers, sensors, actuators, and other electronic components involved in HVAC system control and automation. Variable frequency drives, VFDs in HVAC systems with variable speed motors, such as those used in fans and pumps, variable frequency drives, VFDs, are often employed to control motor speed and improve energy efficiency. While not directly related to bridge rectifiers, VFDs typically incorporate rectification circuits to convert AC power into DC power before using pulse width modulation, PWM, techniques to control the output frequency and voltage supplied to the motor. Backup power systems. Some HVAC systems may include backup power systems, such as uninterruptible power supplies, UPS, to ensure continuous operation during power outages. Bridge rectifiers may be used in the rectification circuitry of UPS units to convert AC power from backup batteries or other power sources into DC power for supplying critical components of the HVAC system, such as control circuits or emergency lighting. Overall, while bridge rectifiers themselves may not be directly involved in the core functions of HVAC systems, they play a vital role in providing the necessary DC power for powering electronic components and control circuits essential for the operation, control, and automation of HVAC equipment. Bridge rectifiers play various roles in telecommunications equipment and systems, primarily in power supply and rectification circuits. Here's how they are used in telecommunications. Power supplies. Telecommunications equipment requires stable and reliable DC power to operate effectively. Bridge rectifiers are used in power supply units to convert AC voltage from the mains power source or other AC supplies into DC voltage. This rectified DC voltage is then filtered, regulated, and distributed to power the electronic components and circuits within the telecommunications equipment, including amplifiers, transmitters, receivers, and control circuits. Battery charging. Many telecommunications systems incorporate backup battery systems to ensure continuous operation during power outages or in remote locations. Bridge rectifiers are used in battery charging circuits to convert AC voltage from the mains or other power sources into DC voltage for charging backup batteries. This ensures that the batteries remain charged and ready to provide power when needed. Rectification and filtering. Bridge rectifiers are often used in rectification and filtering circuits within telecommunications equipment to convert AC voltage into DC voltage and remove any AC ripple or noise. This clean DC voltage is essential for the proper operation of sensitive electronic components and circuits, such as amplifiers, modulators, demodulators, and data processing units. Signal processing. In some telecommunications applications, bridge rectifiers may be used in signal processing circuits to rectify and condition analog or digital signals. This may involve rectifying AC signals received from antennas or sensors, converting them into DC signals for further processing or analysis. Protection circuits. Bridge rectifiers can be incorporated into protection circuits within telecommunications equipment to protect against overvoltage or reverse polarity conditions. These circuits may include surge protection devices, voltage regulators, and diode-based protection mechanisms to safeguard sensitive electronic components from damage due to electrical faults or fluctuations. Power distribution units, PDUs in telecommunications infrastructure, such as data centers and network facilities. Power distribution units, PDUs, are used to distribute power to various equipment racks and cabinets. Bridge rectifiers may be employed in the rectification and power conversion circuits of PDUs to convert AC power from the mains into DC power suitable for powering telecommunications equipment. Overall, bridge rectifiers are essential components in telecommunications systems, ensuring reliable power supply, signal processing, and protection for a wide range of electronic components and circuits involved in transmitting, receiving, and processing telecommunication signals. In industrial automation, bridge rectifiers are essential components used in various applications that require conversion of alternating current, AC, to direct current, DC. Here are some ways bridge rectifiers are utilized in industrial automation. Power supplies. Bridge rectifiers are commonly used in power supply circuits to convert AC power from the mains or other AC sources into DC power suitable for powering industrial automation equipment and control systems. These power supplies provide stable and reliable DC voltage to drive motors, actuators, sensors, controllers, and other devices used in industrial automation. Motor control. In industrial automation systems, bridge rectifiers are often used in motor control circuits to convert AC power into DC power for driving DC motors. This is essential for controlling the speed, direction, and torque of motors used in conveyor belts, robotic arms, pumps, and other industrial machinery. Variable frequency drives. VFDs. Bridge rectifiers are integral components of variable frequency drives, VFDs, used for controlling the speed of AC induction motors in industrial automation applications. VFDs convert AC power into DC power using bridge rectifiers, then use pulse width modulation, PWM, techniques to control the frequency and voltage supplied to the motor, enabling precise speed control and energy efficiency. Control circuits. Bridge rectifiers are used in various control circuits within industrial automation systems to provide DC power for powering microcontrollers, PLCs, programmable logic controllers, relays, sensors, and other control devices. These circuits play crucial roles in monitoring and controlling industrial processes, such as manufacturing, assembly, packaging, and material handling. Power distribution. Bridge rectifiers may be employed in power distribution units, PDUs, and distribution boards within industrial automation facilities to convert AC power from the mains into DC power for distribution to equipment racks, control panels, and machinery. This helps streamline power distribution and ensures compatibility with DC-powered devices used in industrial automation. Emergency backup systems. Industrial automation systems often incorporate backup power systems, such as uninterruptible power supplies, UPS, or battery backup systems, to ensure uninterrupted operation during power outages or voltage fluctuations. Bridge rectifiers may be used in the rectification and charging circuits of these backup power systems to convert AC power into DC power for charging backup batteries and providing emergency power to critical equipment. Overall, bridge rectifiers play critical roles in industrial automation by enabling the conversion of AC power into DC power for powering equipment, controlling motors, driving actuators, and maintaining reliable operation of control systems in a wide range of industrial applications. Bridge rectifiers are key components in battery backup systems, which are designed to provide emergency power during mains power outages or disruptions. Here's how bridge rectifiers are used in battery backup systems. Rectification of AC power. Battery backup systems typically incorporate a bridge rectifier to convert alternating current, AC, power from the mains supply into direct current, DC power. This rectified DC power is used to charge the backup batteries and to power the system's electronics. Battery charging. Bridge rectifiers are responsible for converting AC power into DC power suitable for charging the backup batteries. The rectified DC output from the bridge rectifier is fed into charging circuits, which control the charging process to ensure optimal battery health and longevity. Float charging. Once the backup batteries are fully charged, the battery backup system may switch to float charging mode. In this mode, the bridge rectifier continues to supply a trickle charge to the batteries to maintain their charge level and keep them ready for use in case of a power outage. Inverter operation. In the event of a mains power failure, the battery backup system switches to battery power. A DC to AC inverter, often integrated into the system, converts the DC power from the batteries back into AC power to supply critical loads such as computers, servers, communication equipment, and other devices connected to the backup system. Protection circuits. Bridge rectifiers may be integrated into protection circuits within the battery backup system to protect against overvoltage or reverse polarity conditions. These circuits ensure the safe and efficient operation of the system and prevent damage to the batteries or connected equipment. Monitoring and control. The bridge rectifier output voltage may be monitored and controlled by the system's control electronics, which regulate the charging process, manage battery health, and control the switching between mains power and battery power based on system status and user settings. Integration with power distribution systems. Battery backup systems are often integrated into larger power distribution systems, such as data center power distribution units, PDUs, or building electrical systems. Bridge rectifiers ensure compatibility between the AC power supply and the DC power required for battery charging and inverter operation within these systems. Overall, bridge rectifiers play a crucial role in battery backup systems by facilitating the conversion of AC power to DC power for charging backup batteries and ensuring reliable operation of critical loads during power outages or disruptions. Bridge rectifiers play several roles in renewable energy systems, where they are employed to convert alternating current, AC, power generated by renewable energy sources into usable direct current, DC, power. Here's how bridge rectifiers are utilized in renewable energy applications. Solar photovoltaic, PV systems. In solar PV systems, bridge rectifiers are used to convert the AC output from solar panels, which produce DC electricity, into a form suitable for connection to the grid or for local consumption. The AC power generated by solar panels is converted into DC power by inverters, and bridge rectifiers may be employed in the output stage of these inverters to ensure compatibility with the grid or to charge batteries in off-grid systems. Wind turbine systems. Wind turbines generate variable frequency AC electricity, which needs to be converted into stable DC power for grid connection or battery storage. Bridge rectifiers are used in the power electronics of wind turbine converters to rectify the output AC voltage from the generator into DC voltage. This rectified DC voltage is then conditioned and converted to match the grid frequency and voltage before being fed into the grid. Hydroelectric systems. Bridge rectifiers can also be utilized in hydroelectric systems to convert the AC output from hydro generators into DC power. This DC power can be used to charge batteries for off-grid applications or to supply DC loads directly. Battery charging systems. In off-grid renewable energy systems or hybrid systems with battery storage, bridge rectifiers are employed in battery charging circuits. They rectify AC power from renewable energy sources or backup generators to charge batteries, ensuring a stable and reliable DC voltage for storing excess energy generated by renewable sources. Microgrid and distributed energy systems. Bridge rectifiers are integral components of microgrid and distributed energy systems, where renewable energy sources such as solar, wind, and hydro are integrated with energy storage and grid connection. Bridge rectifiers facilitate the conversion of AC power from renewable sources into DC power for storage, distribution, or grid interconnection. Electric vehicle, EV, charging stations. Renewable energy sources may also be used to power electric vehicle, EV, charging stations. Bridge rectifiers are used in the power electronics of these charging stations to convert AC power from the grid or renewable sources into DC power for charging EV batteries. Overall, bridge rectifiers play essential roles in renewable energy systems by enabling the conversion of AC power generated by renewable sources into usable DC power for various applications, including grid connection, energy storage, and electric vehicle charging. These applications demonstrate the versatility and importance of bridge rectifiers in modern electronic systems where conversion from AC to DC power is necessary.